Okay, in chemistry, we shall handle a number of acids. So we need to know what acids are, what can they do, how do you know that this is an acid and this is not an acid. We need to know that because basically that's what we shall be dealing with. So in this session, we want to know what acids are, okay? How can we classify acids? And then what are the reactions of acids? And then the physical properties of acids and where we actually use these acids. Okay, so that's what we are going to look at here. So acids are compounds that produce hydrogen ions when dissolved in water. Okay, so these hydrogen ions are the ones that are responsible for the acidic properties of the solution. Okay, we can also define acids in terms of what we call protons. Okay, we actually say that acids are proton donors. Okay, because these hydrogen ions are the ones we actually call protons. They're the ones that are being donated to another substance in a reaction. Okay, so the reaction where you have an acid donating a proton and then another substance accepting the proton is basically a neutralization reaction, and we can use this equation here to represent what basically happens. That you have hydrogen ions being accepted by the hydroxide ions to form water. Okay, so in the lab or at this level, we'll basically be interacting more with mineral acids. Okay, mineral acids. So you'll have sulfuric acid, you'll have nitric acid, hydrochloric acid, phosphoric acid, nitrous acid. These are the common acids that you'll basically be dealing with. We often refer to them as inorganic acids. Okay, and then the other category of acids are the organic acids. Okay, they are derived from mineral salts. So that's why we call them mineral acids. Okay, and then we have the organic acids. These are the acids that we get from living organisms or living things. So we have citric acid, the one we find in lemon. We have tartaric acid in grapes, acetic acid, lactic acid, methanoic acid. These are organic acids. Okay, we derive them from living organisms. We look at the concept called basicity of an acid, the number of hydrogen ions produced by one molecule of an acid in water. Okay, so that means that when you dissolve the acid in water, one molecule of that acid, how many hydrogen ions will it produce? Okay, that's what we call basicity. Okay, it is not the number of hydrogen atoms in an acid molecule. That is very important to note. So we have what you call monobasic acids. They produce one hydrogen ion when dissolved in water. We have the basic, and then we have tribasic, and then and others that can produce more than 3 hydrogen ions when dissolved in water. So we have what you call a strength of an acid. An acid, by definition, gives you hydrogen ions when dissolved in water. So what you would expect is that you will have, for example, sulfuric acid, that is H2O. This is sulfuric acid. when dissolved in water, gives you what we call hydrogen ions, which are the ones responsible for the acidity, and then plus the sulfate ions. Okay, so this is yes. Of course, we need to balance this. Okay, so that these are the hydrogen ions that have been produced. This is a complete ionization. You have sulfuric acid giving you all the hydrogen ions. Okay, and then you also have nitric acid. When it ionizes completely to form hydrogen ions plus the nitrate ions. This is also complete ionization. This also makes it a strong acid. The same with the hydrochloric acid. Hydrochloric acid. Let me check the way I've written hydrochloric acid. That is not a good way of writing. You will edit that first part out. Hydrochloric acid. Yes, go back. Hydrochloric acid. You have hydrochloric acid ionizing completely to give you plus the chloride ions. This is yes. This is also yes. Okay. Yes. So that is complete ionization. So we have strong acids that completely ionize when in solution, producing all their or releasing all their hydrogen ions. Okay. So we have those that partially ionize. Okay, that means that they do not completely ionize to give you hydrogen ions. Okay, so you have carbonic acid. To show that they partially ionize or they slightly ionize, we use these arrows, okay, to indicate that these actually partially, this is a minus, okay, this is also yes, so we need to balance that. Yes, so that is what happens with carbonic acid, partially. Okay, so weak acid. And then we have the phosphoric acid. In aqueous, partially, to give you hydrogen ions. To balance the equation, okay? Yes, so these are weak acids because they partially ionize, giving you a few of their hydrogen ions, not completely ionized to give you all the hydrogen ions. So we look at the physical properties of acids. They are shower, they have that shower and sharp taste. When dilute, they are actually colorless, and when concentrated, they are very oily. For example, sulfuric acid. They are very corrosive and can change color of an indicator. We shall see what an indicator is in our subsequent session. Okay, an indicator is a substance that can change its color when whether put in an acidic solution or an alkaline solution. So they help to show us whether the solution is acidic or alkalinic. Okay. And the degree of acidity is or alkalinity is what we call pH. Okay, so for us to know whether the pH is high or low, or which pH is it, we can use what we call an indicator or what we call a pH meter. Okay, so here we're talking about an indicator, which is basically a substance that can change its color to indicate the extent of acidity or alkalinity. So we have examples here. Phenolphthalein, for it is colorless when acidic and it is pink when it is basic. And then we have methyl orange, it is pink when acidic, and it is yellow when it is in a basic solution. And then litmus paper, when it is acidic, it is red. When it is alkalinic, basic, basically, it is blue. Okay, that's what indicators are. So the chemical properties of acids. Acids react with the carbonates or hydrogen carbonates to producing a colorless gas that turns lime water milky. That means that gas is basically carbon dioxide. So when you get an acid, add it to a carbonate or a hydrogen carbonate, then you basically have a gas emitted. You have a corresponding salt and water as the other products that you have. So this is basically an example. It can be calcium carbonate, it can be sodium carbonate, like what we have there. It can be any other carbonate, or it can be a hydrogen carbonate. You have a corresponding salt, water, and carbon dioxide gas as the products. And then we have the reaction with metal acids and hydroxides. Okay, what will happen is that you get a corresponding salt and water. That's what will happen. Okay, so whether it is another oxide here, whether it is another gas, another acid here, you will have the salt and water being produced. Okay, and then you have the reaction with metals. You will often have a gas being emitted, and you basically have the gas that burns with a pop sound, and that is basically hydrogen. Okay, so when you have an acid, add its reaction with metals, you will have a corresponding salt and then a colorless gas that burns with a pop sound, and that is hydrogen, right? So we use acids for a number of uses. In our car batteries, we have acids in there in those batteries. We also use, for example, nitric acid for explosive dyes and fertilizers, and even the cleansers for metals. These are basically made up of, for example, hydrochloric acid. Ethanoic acid is also very used in seasoning of food salads. Okay, so that marks the end of this presentation where we have looked at acids. We have just said that acids produce what we call hydrogen ions. They produce hydrogen ions when dissolved in water. Okay, now we have those that can produce one hydrogen ion per molecule of the acid. We have those that can produce 2 or 3. Okay, the strength of one acid is dependent on how many or how it actually dissolves. Is it completely ionizes to give you all the hydrogen ions? That's what we call the strong acids, or we have those that partially ionize to give you a few of those hydrogen ions. Okay, thank you for listening.